Hello, everyone, and welcome to Fun Steps Academy. Today, we will talk about how mountains are formed. Have you ever looked at a mountain and thought it had always been there? What if I told you mountains are still growing right now? Did you know mountains can rise higher every year, just like living things grow? Today, we're going deep inside the earth to understand how mountains are formed using real geological science. To understand mountains, we must first understand the Earth. The Earth has four main layers: crust, mantle, outer core, inner core. Mountains form in the lithosphere, which includes the crust and the uppermost mantle. But here's the key idea. The lithosphere is broken into large pieces called tectonic plates. These plates are not fixed. They move slowly, about 2 to 10 centimeters per year. Why? Because of mantle convection currents. Heat from the Earth's core causes hot material in the mantle to rise, cool, and sink. This movement drives tectonic plates. Tectonic plates is the unifying theory of modern geology. There are three types of plate boundaries: convergent, plates collide; divergent, plates move apart; transform, plates slide past each other. Most major mountain ranges form at convergent boundaries. Let's examine how. When two continental plates collide, neither plate easily sinks. Why? Because continental crust is relatively low density. Instead of sinking, the crust compresses. This compression causes folding, thickening, and uplift. This process is called orogeny, mountain building. The Himalayas formed when the Indian plate collided with the Eurasian plate. That collision is still happening today. Mount Everest rises about 4 to 5 millimeters every year. Now, here's the physics: stress, strain, deformation. Compression stress creates folds in rock layers. Over millions of years, those folds become massive mountain ranges. When an oceanic plate collides with a continental plate, something different happens. Oceanic crust is denser, so it sinks beneath the continental plate. This is called subduction. As the oceanic plate sinks, it heats up, it partially melts, and magma forms. That magma rises to the surface and creates volcanic mountains. Example, the Andes Mountains. This is why volcanic arcs form near subduction zones. Not all mountains form by compression. Some form by tension. When the crust stretches, it cracks along faults. Blocks of crust can drop down, grabens, or rise up, horsts. This creates fault block mountains. Example, Sierra Nevada. These mountains are formed by normal faults. Sometimes magma pushes upward but never erupts. It lifts the crust into a dome shape. Over time, erosion removes upper layers, exposing inner rock. These are dome mountains. Mountains do not only grow, they also shrink. Wind, water, glaciers, and temperature changes wear mountains down. This is called weathering and erosion. So mountain height depends on balance, uplift versus erosion. The crust floats on the mantle like ice floats on water. This is called isostasy. When erosion removes weight from a mountain, the crust rebounds upward. This is called isostatic rebound. Mountains adjust over geological time. Mountains go through stages: formation, growth, peak height, erosion, low, rounded mountains. Example, the Appalachian Mountains are over 300 million years old. The Himalayas are about 50 million years old. Older mountains are lower because erosion has worn them down. Great! Now let's have a quiz. Question number 1. What drives tectonic plate movement? A. Wind. B. Mantle convection currents. C. Ocean tides. D. Gravity from the moon. That's right. B. Mantle convection currents. Question number 2. What type of boundary forms fold mountains? A. Divergent. B. Transform. C. Convergent. D. Mid-ocean ridge. That's right, C, convergent. Question number 3, what is orogeny? A, earthquake measurement, B, mountain building process, C, rock erosion, D, lava cooling. That's right, B, mountain building process. Question number 4, why doesn't continental crust easily subduct? A, it is colder, B, it is thinner, C, it is less dense, D, it moves faster. That's right, C, it is less dense. Question number 5, what forms volcanic mountain ranges like the Andes? A, continental collision, B, subduction, C, transform motion, D, wind erosion. That's right, B, subduction. Question number 6, fault block mountains form mainly due to A, compression, B, tension, C, heat, D, glacial pressure. That's right, B, tension. Question number 7, what does isostasis describe? A, Earth's magnetic field, B, crust floating on mantle, C, volcano pressure, D, rock temperature. That's right, B, crust floating on mantle. Question number 8, why are older mountains lower? A, less magma, B, lower density, C, long-term erosion, D, less pressure. That's right, C, long-term erosion. I hope all your answers were correct. Comment down below and compare with the others. And now it's time for the fun fact of the video. Did you know Mount Everest is still rising, but erosion is also wearing it down at the same time? The battle between uplift and erosion never stops. Isn't that interesting? Mountains are not just giant rocks. They are evidence of Earth's internal energy. They show us that the planet is alive, constantly reshaping itself. The ground beneath your feet is part of a moving system, and that movement creates the tallest structures on Earth. Thank you so much for watching. Don't forget to like and subscribe to Fun Steps Academy.